So welcome back to another episode of On the Bench with Kixie. In the last video I showed you how to route out a circuit board on a CNC mill, and it was a simple through-hole design, no surface mount components, just for a relay that went through hole soldered on the other side, single-sided circuit board, and a drive transistor and just a few holes to solder wires to the relay drive board. Now this board I just got done with yesterday, and it's a surface mount design. And I'll use a V-bit. This is a 1/10 millimeter at the tip V-bit. It's very small. It seems like it's almost a perfect point. You can poke your finger with it and you'll bleed. It's needle sharp. But it's not a perfect point. It comes to a 1/10 millimeter across the bit. So it's a 1/10 millimeter diameter at the very tip, which is basically chopped off from a perfect point to 0.1 millimeters. And this is the bit, this is the same exact bit I used in my CNC chuck to mill out these traces in between. And around these drill holes. This same bit milled everything you see here except for actually drilling the holes out. So these pads were solid when this tool got done. Now this board is something I made to work with these Wemos D1 mini modules. As you can see, the header pins and the outline of that board is the same as this on the drills. So we're just going to solder a header to this board, and it will be able to, and we'll solder a header socket on this board that goes through, and then we'll be able to just plug these together as a shield so they're stackable. Now the purpose that I designed this board for is to take a K thermocoupler temp sensor and a maxxy max 6675 thermocoupler chip that takes the data from the takes a reading from the K thermocoupler with an amplifier and amplifies the voltage, and then turns that into data over the ISP bus lines to the Wemos module. Now this chip here in the tweezers is not the Max 6675, it's just another chip that has the exact same footprint. Now, as you can see, I placed that IC right onto the traces of this board, and boy and howdy, it fits. It fits. So this is my prototype of what will be a factory-made Wemos stackable board. I'm even going to make them blue, and I'll even have the silk screening there to tell you what the pinout is and all that good garsh. So as you can see, it depends on how much the light reflects off the copper. So as I said earlier, let me move this a little bit. That's pretty good. So as you can see, the IC fits the board traces just fine. You're getting a shadow on the right side, but it's definitely fine, you see? Okay, so I routed out the surface and routed away all the copper clad with this 0.1 millimeter end-mill V-bit, and I set the depth from the surface down to 0.2 of a millimeter. So then what I did after that, after running that batch of G-code on my CNC mill, I left the board clamped down in the same spot. The spindle motor took the tool back to the XY 0 point where it started in the first place. I raised the Z-axis up in the air in order to take this tool out of the chuck and add a drill instead. And this one's a 0.8 millimeter drill. And then I send the second batch of G-code to my machine with that tool after I had Z-probed it back down to the surface and accounted for that, and then I told it to drill 1.5 millimeters deep so that I could drill each one of these holes all the way through the board. But as you can see, these drill holes are perfectly centered damn near on the pads that were there. This bit only routed out everything you see here that's not copper. And then after I changed this tool, I ran a second batch, like I said, with the NC drill file to drill out all these header holes and then the K thermocoupler holes for a screw down terminal connector, or just solder the wires to it, either which. This board is only a single-sided design. I designed it that way because it's only using a simple Max 6675 IC, and I could get all the pins to route out without crossing any lines of the circuit, without having to use a dual-sided board and have a via go through from the top side to the bottom side so the trace could continue without crossing. I was fortunate enough to be able to make this whole surface mount design on a single-sided clad PCB.